This is a DJI Phantom Professional with the 4K camera and the gimbal. This is the Phantom GL300A remote for the Phantom Professional. And the issue is when you have the DJI Go app connected, cabled to your Phantom Professional remote controller, and all you get is the how to connect message on the DJI Go app instead of the camera view. And you've verified that your cable is plugged in correctly at both ends, and you've tried a different cable, then you may have an issue with the communication board inside the remote, which is in the back. And there are 3 or 4 ways to remedy this. You can buy a new remote, you can buy a new communication board on eBay, or you can buy an HDMI upgrade to your communication board, which is essentially the same as the second option, buying a new HDMI or a new communication board. Or the final approach, if you're a tall handy with a soldering iron and you've got a PC to work with it, you can try and reflash the communication board, because it has its own processor on board, and those often become bricked or they lose their programming, so it can't boot up and behave like a communication board like it's supposed to. The next part of this operation is getting the communications board out, which is in this little area right here. So we have a number of hex screws, 4 of them, around the corners, which we are just going to undo. Try not to lose. There's 1, 2, 3, 4. This cover just pops off. And there is your communication board right there. Now, unfortunately, everything we need on this communication board in order to hook it up to our FTDI board is on the underside. So there are 3 screws and 3 ribbon cables to deal with. There's 1 ribbon cable, 2 ribbon cable, 3 ribbon cable. Let's see if I can zoom in a little bit. Oops, wrong way. Okay. So, there are little latches on these connectors. You pop them up. All 3 need to be popped up. And once they are popped up, there's a little rigid tab you can use to pull out the cable. So there's the cable out. You have to be very gentle with these. And the last one down here will actually pull out when the board comes off. So the next trick is the 3 Phillips screws here that hold the board on. 1, 2, 3. Now the board is free, except for the bottom ribbon cable, at which point we just pull that out. And now we have our board. And everything we need to work on this board is on the underside. We are going to be connecting to a number of pads here. These are the UART pads, and this is a reset and 3.3 volt set of pads up here, and this is the 5 volt pad to power the board. What I use to connect to this board is a cable like this. So these have the square pins on the end that are going to plug onto my FTDI board. So what I do is I buy these. They come with 2 square pins, 1 on each end, and I cut one of these in half, and I end up with two of these with just a stripped bit of wire on the end that I can then solder onto the board. The pads we need to hook onto are just these little gold-colored round dots. Unfortunately, I decided to make this video after I'd done it already, so the gold dots I wanted to use I've already soldered to. So the ones that we need here, over here there's one labeled ground, UART0RX, UART0TX. And then over here there's a ground and a VCC 5 volts. That little FTDI board that I have actually puts out 5 volts from the USB port, so that I use that to power this board while we're doing the programming. So I'm going to connect up over here the ground, the UART0TX, the UART0RX, and the 5 volt for communication. And then up here at the top end there is a pad called BT Select, I believe, and it's a boot select pad. And there's another one up there called VCC 3V3. That's a 3.3 volt supply. And you need to connect those two together in order to put it in a special boot mode. So some fine soldering required here. Fine soldering required. Not going to be able to manage the camera and solder. Just tinning my soldering iron here. And the lead that I'm going to put on there. And soldering to the VCC 5 volt pad. Next one I am soldering to the ground pad. Not my prettiest soldering. Let's see if we can do a better job of that. Thank you. Then we're going to hook it up to the RX pad. TX pad. And then as far as the reset goes, the BT SELV pad up here, I'm soldering a wire onto that pad like that. And the other end I'm just going to leave free so that I can hold it onto the 3.3 volt pad when I want to reset it. This is the little communication USB to serial port that I'm going to use. I'll put the eBay link down below. Right now this is the way it came from eBay, and there's two jumpers on it. One of them is on the top, and that jumper actually sets the voltage that it is going to operate at, which is this jumper right here. So that is currently set to the 3.3 volt setting, which is correct for the device that we're using here. It is a 3.3 volt device. I don't know if you can see that there. It says the jumper to the left. The other jumper there is actually just jumpering the transmit to the receive port. So that's basically acting as a loop back right now. So this device alone, if you plugged it into your USB port and used the PuTTY terminal emulator, you could just, everything you typed would go out the port, go through that jumper, and come back, and that's the way to test that you're actually communicating with the device properly. In order to determine which communication port you're going to be using for these operations, you bring up Device Manager and you expand the one called Ports. And you will see right now my system has a COM1 port and a printer port. then you actually take your USB device and plug it in and go back up, and you will then see that it has changed and there is now a COM6 port. So that's the port I'm going to use for any of these commands that I'm going to do. There is a freeware program called PuTTY, which is a public TTY program. So it is a terminal emulator. I'm trying to zoom in here on the icon. That's what the icon for PuTTY looks like. There's the PuTTY icon, that little two terminals communicating to each other. This is what the PuTTY terminal window looks like. And we are going to go to COM6 because that's what we determined from our device manager. I'm sorry, we have to choose serial first. And then COM6. And the baud rate we want is 115200 because that is what the DJI board by default communicates as. And I'm going to save this as a DJI profile. And click Save here, just so that I can repeatedly open this session and communicate with it. So when I open this session, I will then get a black terminal window. It has trouble focusing on the black window. There we go. This is how the board looks when it's hooked up to the FTDI adapter. You can see that I have my 5-volt wire coming under the 5-volt on the FTDI adapter, my ground wire over here to the left-hand ground, the RX wire, or the RX labeled pad on the communication board goes to the TX pad on the FTDI, and the TX pad goes to the RX because they're transmitting and receiving, so they're labeled as to what the boards do. So this board transmits, this one needs to receive that. This board transmits, this one needs to receive that. That's why they appear crossed over. So you hook TX to RX and RX to TX. The PuTTY program will give you an error message when the communication port is disconnected. So what I do is, if you leave the FTDI adapter plugged in, but you disconnect the positive wire, the 5-volt, off of there, the FTDI adapter is the communication port. That way PuTTY will remain happy and you don't have to worry about reopening the session every time you pull it out. So just leave the USB adapter plugged in and you're going to power on the board by plugging in the 5 volts. With the adapter plugged back in, you can cancel the error message if you have one and just do a PuTTY restart session. That will reopen it. Then when you plug in the adapter, you should actually see messages coming out of the DJI board. And in fact, these are the messages that you would see when you have a properly working programmed DJI board. It will just come up and boot into its little operating system that is supposed to do what it's supposed to do. Communicate. Actually, I think it does some transcoding of video as well to get the video signal out to your USB connected device. And that is a normal operating with a dummy read, 68013. So there is a perfectly operating board after the operation has been done. We're going to go back to previous stages and see what it looks like when things aren't working. Okay, I had to simulate this, but this is what my PuTTY window looked like when I hooked up the non-working board to it. You got a message about the DM365 booting, launched the bootloader, and failed to boot because it couldn't find an image. This time I'm going to hold the BT SEL-V wire onto the 3.3 volt as I plug it in. We will get different messages. So now the board has booted into a boot me mode, and it just sits there saying boot me. Once you have the board in a boot me mode with the BT SEL-V shorted, the wire is just touched while it's powered up. You can then close the PuTTY program, because then you need to actually use the programming tools for the Texas Instrument chip that's on there, and you need to bring up a command prompt. CMD is what I use to run a command.exe, and in this command prompt is where you are going to execute any of the commands that you need to actually reprogram this chip. In the folder where I have my command prompt open, which is my downloads folder, I have copies of u-boot_hdmi.bin, ubl1_hdmi.bin, and sfh_dm36x.exe. There's links to a zip file that contains these three utilities, or these three files, in the text down below, so you can download the ones that I used. Bear in mind, these I am using for a GL300A board, and this is just the standard communication board. This one does not have an HDMI port on it, but my understanding is the HDMI, the files that work for the HDMI board work for the board even without, because it still does the video transcoding even though there is no HDMI port on it. And I read this somewhere before I got onto this, and I have confirmed that these files do work for my GL300A with a standard communication board. Once you have your communication board hooked up to PuTTY and correctly operating in the boot me mode, close the PuTTY terminal emulator so that COM6 port is now free and available for the TI programming utilities. That closes that session. And then you can issue this command, which I will list in the text description down below. You're running the SFH DM36, you're going to do a NAND flash, and the port is COM6, and the two files you're using, ubl1_hdmi.bin and u-boot_hdmi.bin. This is where I learned a few things the hard way with trial and error. It will actually do this, and normally, somewhere I read, it would carry on to the next step. And what I discovered was that it stays in this boot me mode even after successfully writing the first part. All you do is hit any key on the keyboard. That will abort the program. The flash program has stopped working. Get rid of the error message. Simply use the up arrow key in your command prompt to bring back the same command, and it will run the exact same thing again, but do a different thing at the end. It will actually correctly write all the rest of the program. So it's merely a matter of doing it twice to get it to work properly. And that is it. The programming is now done. And if we switch over to our PuTTY session again and open our DJI terminal window, it's in boot me mode. All I'm going to do is power off and power on, and then it boots up into the proper operating system, and your board is now ready for you to unsolder the wires that you put on there and put it in your board and connect to your tablet, iPhone, pad, whatever, and get camera view back working. We're now ready to put our board back in our receiver after the programming. The trick here is to make sure that you still have the 3 latches open on here. And start off by carefully inserting that connector, and it goes in. There actually is a line on there. It should go into that line, and then you just push down the latch. Then all I do is get the board in place, pull out those other 2 ribbon cables carefully, and I'm actually going to screw the board in place at this point so that it's held in place. So I've seen a lot of videos on YouTube doing repairs and everything. This whole doing the repair and operating the camera at the same time is much harder than I anticipated. So then I find it easier to go from the top. You can grab that little rigid tab, again insert to the line, and then just push down the little latch, and do the same on the other side. Grab the rigid part, insert it in, do the latch. A wise person would test at that point and see whether it is all working. I have the utmost confidence, and so I am just going to screw the cover back on and go for 100% operational and finished. After you've repaired your communication board, when you have it cabled to your controller, you then should get a view like this. It should automatically detect that you have a Phantom 3 Professional attached, and you should have a button there that allows you to go into camera view mode. Not a very fast tablet that I'm using here. And in camera view you can actually see we have our aircraft status, and it needs some calibration. Try moving it around. There we go.
Addy mode.
And there we go. It is now communicating and actually is getting a camera view of what we are seeing here, which is our remote control.